Welcome everybody to the first video in this multi-course series of the study of trigonometry, where today we're going to be reviewing the trig basics of the three trigonometric functions of sine, cosine, and tangent. So let us begin. Now before we begin, let us talk about what is trigonometry. Trigonometry is the study of triangles, where its applications can be used throughout mathematics and other courses, which can be computer engineering, software engineering, calculus, and polar equations, and formulate when we study about polar equations, which will be coming soon. So let us define the sine function, the cosine function, and the tangent function. The definition of the sine function, or sine at least, is opposite over hypotenuse. Which is the relation found within a right triangle relative to its given angle. Cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. It is very key to note that these trigonometric relations can only exist within a right triangle, in no other shape or triangle other. Let us begin by labeling the angles and sides of our right triangle and their sides corresponding to their angles. Now that we have this drawn, let us complete some examples to see how we can apply what we have learned about the definitions into this example. Let us do sine of A, sine of B. Now, based on our graph above, we can deduce that the opposite side corresponding to angle A is side length A, with the hypotenuse of the triangle drawn in this green color, in the segment at least. Staying true to our definition, we will label this correspondence or ratio being sine of A is equal to A over C. With sine of B, using the same method as before, we find the opposite side of angle B and the hypotenuse, which is still C, labeling as B over C. Now that we have sine out the way, let us move on to cosine. Cosine of A and cosine of B. Staying true to our definition as we have done for our sine function, we know that our cosine definition is adjacent over hypotenuse, as squared and boxed over there. So relative to angle A, we know the adjacent side of angle A being side length B, which is drawn in this reddish brownish shade, with the hypotenuse remaining as C. Therefore, staying true to the definition, being B over C. Likewise, for angle B, we can find its adjacent side relative to angle B and its relative hypotenuse, which remains as C. We know that the adjacent side of angle B, relative to angle B, is side length A. Therefore, rewriting cosine B as A over C. Now that we have this out the way, let us move on to our final trigonometric definition, which is the tangent. Once again, staying true to the definition, we will perform its ratio by looking at its opposite and adjacent sides relative to angle A and B respectively. The opposite side of angle A is, as mentioned before, side length A, with its adjacent side being B, as labeled in that maroon color. So, we can rewrite tangent A as its opposite side being A over its adjacent side being B. Likewise, we do the same thing for tangent B, where we know the adjacent side of angle B being side length A as labeled in this yellow color, and its adjacent side being the yellow color, and the opposite side in this blue. Again, I'm going to relabel it being B right here. Therefore, with the tangent function of tangent B, or the tangent B ratio, that is, being B over A. And as we'll cover in the next video, we're going to be diving into the 3 other trigonometric ratios that are trigonometric functions, and their definitions likewise, as cosecant, secant, and the cotangents, where we'll be also going into deeper review of how these 6 functions are related to one another. Hope you learned something new, and I'll see you soon.